Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. In today's simulation, our students will explore the intricate relationship between temperature, heat, and energy by focusing on two critical phase transitions: ice to vapor and liquid to vapor. Let me open specific heat and latent heat simulation for you. Each simulation begins with a game plan. This outlines the procedures, observations, and learnings of the simulation. If you are a new user, I would recommend you to go through this section thoroughly to maximize your experience. Our main objective of this simulation is to understand the concepts behind specific heat and latent heat. And also have the similar experiment by heating water and analyze the graphs. Let me close this game plan. This simulation have three important points, that is ice, water and quiz. Before getting into the simulation, I would like to introduce the 360-degree angle feature of this simulation. By using your mouse by click, hold and drag, you can view our chemistry lab in different angles. Or else you can use this bottom right button to view that in 4 different angles: T for top, F for front, R for right and L for left. Let's get into the concept. By clicking on this beaker, the simulation starts. It asks us to how many ice cubes we wanted to add to start the experiment. By using this slider, you can fix the number of ice cubes you wanted to cool down. I'm fixing 5. I'm placing this on a tripod stand and I'm clicking on the thermometer to measure the temperature of the ice cube, which is minus 20 degrees Celsius now. I'm going to turn on the stove by clicking on it. It is asking us whether we want to put it on low or high flame. I'm fixing it to the high flame now. As you can see, the temperature is getting increased. The ice cubes have started melting down. The solid state is getting to liquid state. Specific heat and the latent heat are two crucial concepts in thermodynamics that explain how substances absorb and release energy. While both relate to heat transfer, they apply under different circumstances and affect the materials in unique ways. This simulation allows students to explore these differences through hands-on experiments like this. Let's view on the board that represents temperature versus heat curve. As a second curve, we have temperature versus energy. Let me zoom into the board by clicking on it. This temperature versus heat curve will show the sloped sections where the temperature increased with heat, that is specific heat, and the flat sections during the phase transitions, that is latent heat. This curve helps students to understand how heat is used differently during temperature changes versus phase transitions. You can click on temperature versus energy curve to view the difference in energies. I'm clicking on the board again to get the zoom out view. Also, you can make use of this fast forward button to make the process fast. As the next part of the simulation, here we have water. By clicking on this empty beaker, it is asking us to fix how much ml of water do you want to start the experiment. Let me fix 200 ml and click on add water. It is pouring the water to the container. I'm going to place that to the tripod stand for heating. Let me immerse the thermometer to check the temperature. Now it is 20 degrees Celsius, which is in liquid state. I'm clicking on the burner and setting up to high temperature. As you can see, the temperature is getting increased. As you can see clearly how the phase transition and temperature transition happens. Temperature versus energy curve explains the total energy input over the time. The energy increases steadily, but the temperature remains constant during the phase changes, which emphasizing the energy absorbed as a latent heat. The curve reinforces the concept that during the phase changes, energy is used to break the intermolecular bonds rather than increase the temperature. As a third part of the simulation, we have quiz. Quiz gives us an idea how much of our students have understood the concept. Here we have set of 5 questions to be answered. Students have to answer all 5 questions before hitting submit button. Upon clicking on submit, you can check your scores and you can click on check answer to show which is correct and which is incorrect. And also you can click on explanation button to view the explanation of the question. This simulation allows them to see in real time how energy is distributed during the heating process by focusing on ice to vapor and liquid to vapor transitions. Students will gain practical insights into key thermodynamic principles that apply to everyday phenomena such as boiling water or understanding how cooling system works. Thanks for watching.